Hello. All right, everyone. So yeah, this talk is about service workers and service workers in Angular. And I want to talk about how to make applications offline, so that they work offline, right? We will take a look at service workers as a general API, so how they basically work as a native API without Angular, so that you get an idea of what the API looks like, so that you can use them yourself. And then we will take a look at what Angular provides you so you can use service workers in your applications. Because Angular comes with a very special integration to that, which is pretty cool. So there was already an introduction. My name is Pascal, right? You can find me on Twitter. Who's on Twitter here? Right, so that's the handle right there. How many people? Hands again. That's about 30 or so. Okay, I expect 30 more followers now. I do some training at thoughtram, so if you're interested in Angular stuff and training, I do that as well. Okay, so a couple weeks ago, the new Angular website has been launched, right? So this is a new website that actually uses service workers behind the scenes, which is pretty cool. So the service workers integration in Angular is an integration that is right now still in beta, but it's actually in production in Angular. It's the first pilot project that actually uses that technology. So everything I'm going to talk about today is going to be in beta as well, unless Igor comes up with another tweet and says that 4.3.0 is out. So this is what the website looks like. In fact, what we will do today, we will take this website and I'll guide you through some steps how to make it work offline, right? We will start online and then we make it offline step by step. There's another tool called Lighthouse, which gives you great benchmarks over if your application is a good so-called progressive web app. So a progressive web app is a special, or is a kind of buzzword right now these days, which kind of describes what features your application supports and if it's a well-built application or not. So some of these features are things like service workers, for example. Does it work offline? Is it served via HTTPS? Is it responsive, right? These kind of things. So many of these things you already know. We're doing this since many, many years, actually. But they're now kind of, all gathered under one single word, progressive web apps. And so this is basically the benchmark of the Angular website. So we can see 100 points, progressive web apps, which is pretty cool. There's still some room for performance, but I mean, there's always room for improvements, right? Okay, so service workers. Let's talk about service workers. Again, in the progressive web app landscape, there are a couple of things that you need to consider when you build a progressive web app, right? So there's things like has to be progressive, has to be responsive, progressive in the sense of progressive enhancement, so it should work in pretty much all browsers, right? It should be connectivity independent, so it needs to work offline. It should feel like an actual app. It should always be up to date. It needs to be safe, so served via HTTPS. Discoverable, which is pretty much what the app gives by default, using links and stuff, which is pretty cool. And lots of other things, like even installable, right? Web apps can be installable. Like those are the things that or some of these features are things that, cause people to actually choose native applications. And so the ones that are highlighted here are actually the features that you get from service workers, right? It's actually, it's a technology where browsers kind of gave up solving the problem of making applications work offline. So now they give us the tools, the APIs, that we can use to make our application work offline, right? All right. Okay, so a service worker, in one sentence, is a script that runs in the background separate from the actual web page, and it opens the door to features that don't need any user interaction. So this is a super important thing. Like, this service worker is just another JavaScript, so you already know that, you know the syntax, you know the language, right? You don't have to learn anything new. It's just another file where you put stuff, where you put logic, and it's somehow magically executed. So you don't really have to worry about that. And it doesn't need user interaction. This is like a very, very important thing. So you can install service workers, you can update them, they can react to certain things, and we will see that in a second. But the user doesn't really have to do anything for that. So in fact, you provide cool features like offline capabilities without the user, without the user having anything or taking any action. So some facts about the service worker. A service worker is a JavaScript worker. So again, a separate script, kind of like a separate task or process, if you will, and it cannot access the DOM. So it's a JavaScript that doesn't have global state, and you cannot do any DOM operations. It actually communicates via the post message API to your website. It also serves as a network proxy, which is kind of important. So basically, you can imagine this thing as sitting between your web application and the the network connection. And if the browser starts requesting things like CSS and JavaScript and stuff, the service worker is actually the one that's taking care of that. And that gives you the opportunity to actually chime in and say, OK, I don't actually want to go to the network, but actually I want to take this from cache and give it to you, which essentially is making things working offline. Another thing that's pretty cool is that they're terminated when they're not in use. So basically, if your service worker is installed and it doesn't have to do anything, then the browser basically shuts it down. It doesn't take any memory or whatever, which is pretty cool. OK, so what are the features and use cases? Pretty obvious. Reliability is the biggest thing. So you want to provide static, but also dynamic and external resources from cache. Basically, making your app work offline, making them fast. This is the next point. You get performance basically by default, because instead of going out to the network, you just serve things from cache. That's pretty much instant, which is cool. And it turns out there are other technologies like push notifications, for example, which you can implement with service workers as well. So if you ever have someone telling you, yeah, I prefer native because I have push, you have this in the web too, seriously. And there's many more things to come with that. All right, so service workers support in browsers, actually kinda decent. So if you're on Chrome or Android or whatever, that should basically work. In Safari, it's right now under consideration, and Edge is implementing it right now. So it's actually pretty good. All right, so let's take a look at the service worker APIs. And once we've done that, yeah, we will take a look at the Angular integration, and then we take this Angular website and make it work offline. So first of all, we start off with the service worker lifecycle. That is the lifecycle that every service worker goes through. So basically, this is our browser. We start off with no service worker at all. And then there's this installation process. This is basically when you tell the browser, hey, I have this service worker script, and you need to install it. And this process can either fail, or it can succeed, and then it activates the service worker. When you enter the activation process, or when the service worker enters the activation process, it basically is like idle. It's like sitting there and waiting for messages so it can do things for you, right? So it takes either, it responds to messages, that's where the post message API comes into play, or you can use like fetch APIs in the service worker to do things like fetching stuff from the network. So again, the service worker is a separate script, doesn't have access to the DOM, but you do have access to network and you have access to cache and stuff. And if it's not doing anything, it's terminated. OK, so let's take a look at what that looks like in code. Obviously, we want to check if service worker is supported on our browser or not. And then there's this simple call, navigator.serviceworker.register, which simply points to another JavaScript file, which is essentially our worker. And that's just JavaScript. There's nothing special about it, right? You all know how that works. So it's not scary or anything. Returns a promise. You can react to that if you want to. And the service worker file, basically, we will see that in a second, has a certain scope that it takes care of. So if you register a service worker for the domain example.com, all requests that are being performed from the browser for example.com will be kind of proxied by the service worker. The cool thing about this is you can basically ship that to your clients for every request, because it's just, the browser is smart enough to figure out if the service worker is already installed or not. So it's not a concern to call register multiple times. All right, now let's go to the service worker itself. This is what it looks like when you basically install the service worker on the service worker side. So there's an install event that you can listen to. Again, no global state. You only have events. Install, you have an event object, and this one has a method wait until, which returns a promise. And wait until basically tells the browser, hey, I'm doing stuff. Please do not terminate me until I'm done, right? And so the install event is the perfect event to tell the service worker, hey, these are the resources that we want you to cache right away, so that when the application is offline, it works offline. So we have an API, caches. That's the cache API. We have access to that in the service worker. And we can create a new cache using the open call, or the open method, which returns a promise. This is another thing I should have mentioned. All the APIs in service workers are pretty much all promise-based. So you should know how promises work if you want to use these APIs. So when we get the cache that we just created, we can actually add files to it. Or in fact, what happens, we kind of add requests objects. So you can see here that we're saying we're basically caching everything that's in slash styles, main CSS, and so on and so forth. You can really see that as an array of request objects, right? So this is what happens now during installation when the browser installs the service worker. So this event is pretty good for getting things done before any other events are handled inside the service worker, right? So you basically want to install everything that is needed so that the application works offline. We use wait until to defer possible termination. Again, if you don't do that and whatever is happening inside install, it can cause the browser to actually terminate the service worker if it doesn't return a promise. Another thing that's super important is as you're installing your service worker, there might be already a service worker active on the page. So you do not want to do things that interrupt the old version of that service worker. Because when you install a new service worker, the old one is going to be active until all tabs are closed that still use the old one, right? So don't do anything that breaks an existing service worker in the install event. This is ideal for static resources. All right, so now we have a service worker installed. Let's take a look at how we can actually return stuff from cache when the browser requests stuff, so that it doesn't actually go out to the network, but takes stuff from cache. We have a fetch event that we can listen to, and we get an event object with a respond with API, which also returns a promise. And then what we can do is we can basically see, using caches.match, if there's already something in cache that matches the request object that we get. So if the browser requests main.css, basically this would either match or not. And depending on if it matches or not, we would either return what's in cache, or we just actually reach out to the network. So it's basically try cache, fall back to network. Does that make sense? Awesome, cool. So, but what if we actually want to, what if we fall back to the network and then actually want to cache that stuff? Because obviously it wasn't in cache, right? That's why we reached out to the network. Then it would look something like this. So this is exactly the same code, right? A little bit different formatted. But again, we check if we have actually something in cache. We return it if we have it. If not, what we can do is, again, we fetch the request. What you see here is we clone the request object, because it turns out that both request and response are streams and they can only consume once. We actually end up consuming these things twice, and you will see that in a second. And because we do that, we have to clone it. So we have the request object, we consume it using fetch, we perform the actual network call. Then we check if the response was okay or not, right? If we get a 404 error or whatever, we want to return that response object, which will basically be the default behavior of the browser. Otherwise, we basically take the response, we clone that again, because it is a stream. We need to clone it because it can only be consumed once. And then we open our cache, and we basically put our request object into the cache with the response that we got from network. So this is where you can see where response and requests are being consumed twice, which is why we have to clone them. Okay, so fetch event executed on every request made by the browser. This is good for cleaning up cache. What I mean by that is if you, for example, fetch data from Netflix, like images, right? Sorry, Netflix, Flickr. It's all about media. Basically, if you fetch dynamic data, you might want to update your dynamic data in cache as well, like images. And you might also want to get rid of old ones that are not interesting anymore. This can happen. So this is what I mean with cleaning up cache in this case. And again, request and response objects can only be consumed once. And yeah, this is ideal for frequently updating resources, dynamic data, basically. Okay, so now that we have our service worker installed and we actually return stuff from cache, what if we want to update our service worker? What if there's a new version? What if we have something else that needs to go in cache, and maybe we even change the structure of the cache or whatever? This is where the actual activate event comes into play. The one that we've seen at the very beginning with the lifecycle, when you have first install and then activate, this is what we see right now. So this is what happens. Basically, what we could do is we could say, okay, we create a new cache, maybe one with a different structure. We don't want to break the existing one. And what we do is when the activate event is fired, we basically iterate over all caches that we have. And so this is with caches.keys. You get the cache names. And then basically what we do is we check if the cache that we're iterating over is part of our whitelist. In this case, our whitelist has really only one cache, which is just the next version. And we make that name up, by the way. It's your call. You can call it whatever you want. And then we delete it. So this is basically the perfect moment where you can delete stuff, because when the activate event is being fired, we know that all existing previous versions of the service workers have been terminated, right? So this is basically why you have install and activate. Here you basically clean up everything you don't need anymore, or if you want to do migration, stuff like that. Okay, so again, call when previous service workers are deactivated. We do not want to make this a long thing, because things like fetch events are actually queued up in the browser task loop. And if you have a long activation, this could basically block some calls. So keep this as minimal as possible. And yeah, as I mentioned, ideal for cleanup and migration. All right, that's it. That's service workers. You now all know how service workers work. It wasn't complicated, right? Very straightforward APIs. Okay, cool. So now let's talk about the Angular integration. What brings Angular to the table on top of that? Like, what else do we need to do to, can't we just use it like that in our Angular applications? The answer is yes, of course. You can just go ahead, use these APIs natively, write your own scripts, and just make it work. Totally fine. Or you use Angular's magic integration that basically does all the work for you, which is pretty cool. So everything that I'm showing right now, you can do yourself with native APIs totally, but you don't have to. Okay, so the Angular Service Worker is basically already it's kind of an abstraction layer on top of the native APIs, and it's a ready-to-use implementation. We can use it just as it is. We can install it there. We will see that in a second. And then we can just use it right away. It already takes care of managing the cache, installing everything, having a activation routine that is decent enough to actually handle all updates and stuff like that. And it also comes with a nice plugin system to handle things like dynamic routing, dynamic data, and these kind of things. This stuff that we haven't really seen yet. And another important thing here is that the Angular Service Worker consumes a manifest file, which we'll see in a second. It's basically a JSON file that comes with some configuration, and we can use that to configure the service worker without actually writing the service worker. Okay, so it takes care of all the bulk work, installing, updating, managing caches. You don't have to do that. When do we want to update the cache? How long does data stay in it, and stuff like that. Dynamic routes, dynamic data, external resources. What does that even mean? We'll see that in a second. Okay, so installation. There's a package, Angular/service worker, npm install that, and you have it. And if you're in an Angular CLI project, which I recommend, then this is almost all the work you need to do. Because Angular takes care, or Angular CLI takes care of adding that service worker that you just installed to your application, like magically. And here's how you do it. And this is no joke. This is really how it works. So if you ever want to have this magic button that says make it work, here you have it. So this is the Angular CLI JSON. Who's done some Angular CLI projects here? Okay. Well, this is the majority. For those who do not know what this is, if you have an Angular CLI project, you have an Angular CLI JSON file. It's basically a configuration file that lets you configure a project. Pretty straightforward. And so there's this one section apps in which you can just say service worker true. Yeah. That's it. And then, or you can set it like this, like manually. You don't have to. You can do that on the command line like that, ng set something something. I like to go into the JSON file and do it manually. And that's doing the whole thing, like literally. So basically what happens behind the scenes is that the Angular CLI is going to add a script to your index HTML file. And it's important to note here that service worker support, in that sense, an Angular CLI only works for production builds, which makes sense, right? So you build for production, you get your build artifacts that are, hashed and everything, and you want to use service worker on that because, that's the data you want to cache. And basically, in your index.html, you get this register file embedded. This is just a registration process, the one that we've seen a couple slides ago, right? No magic in there. So it adds that to your index.html in your distribution folder. So after you created a production build, and then it generates a ngsw manifest JSON for you. That's the configuration file I mentioned earlier. So it creates that for you, and then basically your application is, I don't know, 80% offline, like works offline. I can quickly show that really quick here. So basically, let me see if I can. Oh, this is, by the way, not my machine. Due to some technical issues, I'm doing all of this here on a machine that I don't know. So that's going to be fun. So basically, what we see here, this is localhost. I built Angular.io on this local machine, and I serve it statically on localhost. That's it. And so we can see this is nice, it works. And here, if we open the DevTools, there's a tab application. Here you can actually see under service worker right here, you can actually see all the registered service workers on that website. And we see actually that there's one running right here. So what I can do is I can update on reload, which basically means even if there's a service worker, always reload all the data from network. So let me actually clear the storage. So I'm gonna remove the service worker now. We can still see it, but if I refresh, I go to the network really quick. Let's go, for example, to some JavaScript, and actually let me see if I have it already set up correctly. Yeah, I'm gonna zoom in here a little bit. Okay, so I'm going to refresh the page, and we see that everything's going to fetch from network. That's fine. We have Ajax calls here, CSS, images, all from network, right? So, but now, at this point, this service worker has been installed. And you know how the process works, right? Install, activate, and so on and so forth. It has done the work. We can see that, again, if we go to application, we can see it right here. It's sitting there waiting for, doing stuff or not. So if I actually go ahead now and refresh the page, we can see that right here, it actually serves everything from service worker. So this is already all being served from service worker. If you want to be really sure if it works or not, you can go to the service worker panel like this, click offline, and then refresh the page again, and you'll see it still works. So this is basically Angular.io after setting service worker to true. It works offline. I'm offline. I can still serve around and click here, click there. This works offline without doing any further work, which I think is pretty cool. But I seem to be the only one here excited about this. Yeah. Okay. Cool. So, but this is really just the static data, right? So I'm offline now. If I actually now go to another page that I haven't seen before, or that actually loads data dynamically, let me do it right here. We will see. Oh, am I still connected? Let me see. Not found. There you go. Yeah. So there are a couple of things missing. So let me go back to slides, and then we'll see that in a second. So basically, it created this ngsw manifest file, which configures all the plugins for the service worker, the Angular service worker, including static and external content resources. That's why this website just worked just like that. Dynamic resources and routing redirection. Now, what does that all mean? If we take a look at the ngsw manifest file, we see that there's the static property with a lot of resources, and I'm going to show you right now. This is first time me and VS Code. Okay, so this is inside the generated disk. This is what the ngsw JSON file looks like right now. So you see it automatically gathered all the static resources inside that project and added it to that file. And this is how the service worker knows that it has to cache this stuff. Okay, that's static data. Cool. In fact, what we can do is, and let me see if I can actually make it work here. I can create my own ng manifest file in my root project, and if I rebuild the project, it's going to merge the one with the one that the build actually creates. So I'm not going to rebuild the project now because it takes ages. I'm going to, for example, take this external resources list here, and I'm going to put it here into the one that is in the generated dist. I'm going to save it. And if I go back to the application, we can actually see, again, I'm going to clear the storage. I'm going to refresh the page. We can see the service worker is again installed. I can go offline, go into Network tab, refresh the page. And we can see that external resources are also coming from the service worker. So this is how you do it. If you have any external resources, you just add them right there. This is, again, also pretty much like static content cache. You see that there are a lot of hashes. This is because out of the content that comes from your source files, hashes are generated, and that basically tells the service worker, hey, this is exactly this version of that file. So if that hash doesn't change, the service worker knows it doesn't have to update the file or recache it. Okay, static, external, we've seen that. This is great for stuff you don't have control over. What about route redirection? What is this even all about? Let me show you something real quick. So basically, if I go ahead and I'm going to, again, clear the storage, and I'm going to refresh the page like this. Now, let me actually see if I have it in here. This is that one. Yeah. Okay, so now if I go offline and I refresh the page on localhost 5000, this should not work. Let me see. This app is smarter right now as it should be for some reason. I think. Let me just be sure if I'm working with the right file here. And I'm very new to this VS Code thing as well, by the way. So in dist, ng, oh, that's right here. So it magically knows the dynamic routing. That's interesting. So actually, the problem that I wanted to show is if you don't configure the service worker and tell the service worker, hey, if I go to, for example, if I go to index.html, obviously I get index.html, right? But if I navigate to another page, let's say tutorial and the hero editor, now I'm in /tutorial/something. If I'm offline, which I am right now, and I refresh the page, you will see not found, right? Because the service worker doesn't know what to do when you request this page. There's nothing that tells the service worker, hey, when you actually go to /tutorial/something, also serve the index.html file. And this is what dynamic routing is about. So you basically need to configure your service worker and tell them, hey, look, if I'm going to, visiting these URLs, also serve the index.html file. And there's a nice configuration for that. And it looks something like this. So you have a new section routing, and you say, my index file is /index.html. And by the way, if I go to I can say prefix false, which means if the request matches exactly that path, it serves the index.html file. But what if you have a block and you have like many different paths, right? /block/post/something. You don't want to write them all in there. It's pretty cool. What you can do is you can say prefix true, which basically says everything that is /block/ and whatever serve index.html file. Or what you can do is you can use a regex. In this case, Angular.io use this one to say basically always serve the index.html for any request except for requests that go to Plunker because we don't want to serve index.html when we have an embedded Plunker or whatever. So, and I have it right here. I'm going to copy that over. Again, usually you would just have it as part of your, you would just rebuild the project, and it's going to put that into your index, sorry, in your dist manifest. I'm going to save that. And if I go ahead and, again, clear storage to be super sure, and I go to localhost 5000. So what I can do now, I can, I'm online. I actually go to fundamentals, forms, something. We see it loads, obviously. OK, so now I'm going to go offline. I navigate to a page that I haven't been to yet, form validation, for example. Or which one am I right now? User input. OK, so let's go to form validation. So this is going to fail because I'm offline and I haven't, seen this document yet. It's not, the service worker hasn't seen it yet. But if I go back to user input, you see it's right there. Because now it knows, due to this routing configuration, that it has to load that, or that it has to serve the index HTML file. Pretty cool. OK, that's routing, redirect, and then there's a dynamic data. Basically, what if you have, like JSON data that is being fetched from the server at runtime? For example, we have some documents here in this project that are based on a JSON file that are fetched at runtime. And right now, our service worker doesn't know these. So if we try to go to a certain document, we will see that the loading will fail. And it's pretty cool. What we can do is we can actually tell the service worker, hey, look, please also load these, this and that data. And there's some nice configuration. You can either perform this dynamic data cache for performance or for freshness. Performance says always serve from cache first, and then basically try to cache updates. So basically, go to the network and then cache the data. Or for freshness, which basically means always go out to the network and fall back to cache if it's needed, which is pretty cool. And the configuration is also pretty straightforward, a bit more complex though, because there's much more you can configure. So you basically have this dynamic section with group. You give it a name. In our case, for example, guides. So if I go online here and I go to network and I'm going to clear this out, let's go to HX, and I'm going to click on, let's say, bootstrapping. You see that we actually fetch bootstrapping.json. And so what we can do is we can say the following URLs are the ones that we want to cache as well. For example, in this case, let me actually show you the exact path. It's /generated/docs/bootstrapping.json. Now, what I want to do is I want to say, please cache everything that's in /generated/docs/something, right? So that we cache all the dynamic data. And we can do it like this. So we say /generated/docs, and we again say match prefix, which is exactly the same as the one that we've seen before. And what we can also do, and this is where the optimization comes into play, we can say optimize for performance. It's like another button that you can just press. Or you could say freshness. Yeah. And then there are some caching strategies that the Angular Service Worker supports. So least frequently used, or first in, first out. So this is depending on what you want with your data. You can configure it right there with a couple of words, and that's it. Pretty powerful, without you writing any line of code for the service worker. We've seen a couple of demos already. OK, we can do much more. There are things like we can actually go ahead and inform the user that there's a new update available. So we can basically make the service worker figure out that there's a new manifest file. And maybe you've seen it already somewhere here. There was a little tiny notification that said something like this. So it turns out that Angular already supports that. It's already implemented right there. Another thing that's going to be supported in the future by Angular CLI is that the route redirection is generated for you automatically when you build your project. So you don't have to go into your NGSW manifest file and create the configuration manually for all of your routes. It's going to do it for you, just like that. Magic. And obviously, as mentioned earlier, there are other features like push notifications, background sync, stuff that we haven't talked about today. But these are all the features that you can use to make your applications re-engageable, more performant, more fun. I would like to give some credits to these people here for this talk, otherwise it wouldn't have been possible. There's Jake, who actually created or wrote most of the service worker spec, Alex, who actually built the Angular service worker, and Maxim, who reviewed my content here. Ari helped me with understanding regex, and of course everyone who built the Angular website, which I think, the new release is great. It looks really nice. There's some resources right here. The slides are already up online. You can follow me on Twitter. I'm gonna like share it right away, and that's all I got. Thank you.